I'm Shiv. I'm Shiv Iyer, founder and principal of MinervaDB. Um, so I just want to talk quickly about me. I'm an open source database systems operations geek, and also the founder of MinervaDB, with core focus, interests, and performance, scalability, high availability, and data SRE. Over 18 years, I'm in open source database systems, work for some of the best companies, starting with MySQL Sun, MySQL Sun. Mostly I was working from Asia Pacific and Southeast Asian offices of Sun. Um, Worked as a data SRE for PayPal, eBay, AOL, National Geographic, Pinterest, Yahoo Japan, Percona, and PalamoDB. Currently, I'm the founder and principal, as I said, with over 350 customers worldwide. Most of them are internet properties. 90% of our customers are internet properties. Um, so that means the rest of the 10% are ISVs. And that really has some connections to today's talk. Migration talks, MariaDB migration talks. Most of that started as curious conversations with some of the independent software vendors who are into the business of providing software infrastructure for banking, financial services, insurance, and also connected devices for healthcare business. Interestingly, both of them carry a lot of sensitive private data. So when they started talking to us, like they started conversation like, "Hey, we need an alternative for Oracle, open source free software for Oracle, and we can see you guys provide support and services for open source database systems. Um, Interestingly, we provide the same what our then prospective customers was interested about, MySQL and MariaDB. The conversation started. The biggest question for us was like the privacy and security. Or then a question, it was like biggest concern. And the conversation started like, hey, we're happy that we're getting a community supported open source free software database systems infrastructure. But then, what about the privacy and security? So every day, every meeting we had, there was a conversation in privacy. So I'll talk about that in detail. Um, of course, performance rules the transaction processing system, data processing systems. Scale. Most of the banking, most of the health tech companies have uh, now their consumer-facing internet applications on mobile devices, or maybe even on the wearables. So scale was definitely a big thing. The transaction should be reliable because sensitive data, which is governed by both the law of the land and other industry compliance standard. The, the biggest concern started at some phase of a conversation, which was also leading most of the conversation was like the complexities in open source licensing. Some texts were even not clear for the corporate lawyers. So we even had an opportunity to sit with some of the lawyers and read the licensing norms. GPL was quite easy for everyone to understand. There was nothing missing between the lines, or something was gray between the lines. So GPL was good. BSD open source licensing was the one, but luckily we were in talking PostgreSQL then. The cost of maintenance operations, like this was, I talk about this in our slides, other slides, but then maintenance operations, licensing complexity, privacy and security were the leading topics of our conversation. So what was so exciting about migrating to MariaDB? One, we are a big MariaDB fan company. Most of our engineers most of our consultants are from MySQL AV, from MariaDB, or they supported MariaDB or MySQL for some of the largest internal properties. Um, Open source, free, and community powered project was really a big point of our interest. And again, the Oracle, they were all Oracle customers. They are all then they are all completely an Oracle shop. Their entire application was built on Oracle. So definitely they were looking for how we can have another database system which is 80 to 85% compatibility, or the feature rich like Oracle, and how we can evaluate. Uh, and So the conversation was always in that direction, like, hey, licensing complexities, the cost of ownership of license, and the investments on the infrastructure for building an Oracle powered database application. And interestingly, very interestingly, the DBS Bank story evolved somewhere close to that time period. Um, so MariaDB support DBS, and that story was used several times. Hey, look, there is a bank in Asia Pacific, Southeast Asian markets. They are on MariaDB. Also, there are a lot of internet scale data infrastructure, um, like Google, Red Hat, Wiki, Nokia, and several of our customers to be at least close to this volume. So we used to show them, hey, something, we process approximately 300 billion ad impression for one of the largest ad networks in the world. Very write intensive, completely on MariaDB, and it works great. So yeah, a lot of production level benchmarks and the matrices we shared, so that they get some idea, like, we are talking something sensible. As we increased our frequency of conversation, the topic was always like, hey, how much I have visibility to the database performance matrices? What are the native tools provided, supported by MariaDB to give us visibility to troubleshoot more efficiently? Uh, Definitely, there was no compromise on the reliability, and the availability was one of the key areas. Like, uh, so the system should be capable of a redundant database infrastructure. Um, there should not be any single point of failure. There should be a MariaDB aware load balancer in place, which takes care of the failover. Like I said, there was no scope for data loss. It's a financial institution which also supports several healthcare providers. That means they provide insurance, they provide um, they, are, they have an extended connections with the the systems which takes care of the several sensitive healthcare sensitive databases. Support was always a conversation topic. Every time when we tell, like, hey, something, we can build a highly reliable, fault tolerant, self-healing system on top of MariaDB. The first question is like, hey, are you sure that this scale of infrastructure we get people to support? So yes, uh, we, so we so it was a good time, actually. Like, we talked to business, we talked to the community people, but it was a very interesting phase. Um, Capacity planning and sizing. So when I used to talk to my customer, who always 30%, 40% made up their uh, interest, that he knows something. When I say 30, 40%, it's like our frequency started increasing, frequency of meetings started increasing. Like, it used to be like twice a month, started becoming once a week. Then it's moved to a phase that every second day we'll have a conversation about, are we going to use the same capacity for this MariaDB infrastructure? Do we need to oversize it or undersize it? how is going to be the efficiency, performance and storage efficiency on SSDs, um, and how we can tune to make MariaDB even faster. And most important, what I have seen gone wrong terribly on MariaDB. So, so we were very honest, like there are good stories or bad stories. So I talk about this. But this was our checklist of choosing MariaDB, or like this is a business checklist. This is a checklist which has been which evolved after several meetings with the customer. Enterprise class database infrastructure. That means like data reliability for web scale. So when I say data, right, there's a lot of differences with the customers we have worked in the past with working with the financial institutions. We work with the ad tech companies. We work with gaming companies. We work with some of the SaaS. There are really traffic intensive. Some of the biggest e-commerce companies. They're really big in traffic. But when it comes to transaction sensitivity, right, or transaction durability, reliability, demand, the financial institution and the the that includes core banking, insurances, and also the the, the healthcare software companies with whom we used to work. It does look very heavy, at least for us who come from an internet data infrastructure operations background. So data reliability for web scale, performance always the demand was like how many number of transactions we can process if we scale our business from X to 5x. Scaling horizontally. Hey, this is something very interesting. Like Oracle don't have a horizontal scalable solutions, right? They talk something called real application cluster. I'm not a serious Oracle guy. I read a lot of Oracle books. This is purely out of my technical interest, but I don't work on any production Oracle system. So when I was looking at like, hey, you talk on most of the meetings you talk about scalability. How do you work on it? Somewhat of I understood that when they say scalability, it's about shared everything architecture scalability, which something what Oracle call as Oracle real application clusters. Um, but in the world of MariaDB, we have something called shared nothing architecture. And trust me, I took one complete week to finalize, or then finalizing it is like one complete week to uh, create a document which talks about how shared everything works, how shared nothing works for the business team, and communicate, convince, and finalize on how shared nothing architecture works great for a web scale and cost efficient. Fault tolerance system should be available all the time. Um, Fintech companies. So most of them were graduating from a bank to a fintech company. So highly reliable system. Data privacy security, very important. Synchronous and semi-synchronous replication was one of the key topic. Reason because like when we say there is no scope for single point of failure, that means that in a distributed redundant system, what could be the worst thing can happen is like if there is a database instance crash or primary database instance crash, um, what's going to be the data loss impact on the business? Pretty high, seriously, pretty high. During the key business hours, very, very high. The numbers were like quite shocking for us. Like we never thought like, okay, what happens if a banking system goes down by 5 minutes or 10 minutes? Um, the numbers are too big, really big. So there have been always some. So when we go for some meetings, we're being like, wow, the MariaDB is great. Like this is good. This is something which takes care of our data of the future, right? Data infrastructure of the future. When we go for other meetings, like we can't compromise on data loss. Data loss means the loss for the business. Plus, there'll be a lot of statutory guidelines which could make severe impact on the professional career of the senior executives of the bank. So yeah, there was no scope for that, and we need to really spend a lot of time in making them understand like how MariaDB replication addresses the synchronous replication with Galera cluster works to make sure that it's everything or nothing. There is the transaction either get completed or get rolled back in a distributed system. Point in time recovery, yes, audit, transaction audit. That is completely on the statutory guidelines. Columnar store for data analytics. So there have been like, hey, we use Oracle, we use Exadata. That's a appliance of Oracle that works great for analytics. We use something like Exalytics or something, a lot of things. So the idea was like, Oracle is a single vendor for me for now for database infrastructure. Now, when I move to MariaDB, it's something like I'm going to have multiple vendors. Answer was like in MariaDB, we have definitely the infrastructure to power your different varieties of SQLs, different variety of queries, like or transaction queries are taken very well, gracefully by storage engine built for asset compliance systems. If you're looking for analytics, definitely MariaDB solves that. If you're looking at, so we need to explain them. There is a difference between storage engine, which is very MySQL, MariaDB specific systems. Or it's a very, very specific to MariaDB or MySQL. Compared to Oracle, we don't have something like storage engine there. So it's like when I used to go for the meetings, like I used to like, hey, something we can use DB, we can use area. Maybe after a day or two, I got a question like, do you mean to say these are the two different database system stack from MariaDB? I was like, no, this all be inside single MariaDB. So yeah, how can we troubleshoot more proactively? Systems can behave awry, weird. It's acceptable, but then we should able to troubleshoot them. So what are the technology infrastructure MariaDB provide to troubleshoot MariaDB even better? Optimal indexing, and how is the indexing MariaDB work different from Oracle or Microsoft SQL Server? Disk IO performance optimization, partitioning capabilities, and tolerance and partition pruning. Again, every of our conversation, every of our bullets on the meeting will have a HA, like high availability, and upgrades and migration. This is the last points in our most of meetings, but then at some point of time it was like, the cost of upgradation is something very high. The proprietary software, big business because of the licensing complexities. But then now open source, what you see is the complexity is like one, what's going to be the 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 reliability of the new release, and what's going to be the responsiveness in the bugs reported, and how the workflow work. And so for that conversation, we even pulled out, MariaDB is not just a new company. It's been built by the business, by the team, by the community, who have spent several decades on database systems. So we even started pulling this. Okay, this presentation I have used from CIOs, CTOs of multiple banks and several hospitals with my ISV partners. So I go with my ISV partner. My ISV partner tell like, hey, something, we are coming with a new database system. Some of the banks was like, no, it's okay. So, but then when we say that new database system is from MariaDB, and remember these guys don't have any exposure to open source systems. So we say like, this is built by the people who are database systems geeks. They power Google. They work with Facebook. So they are very, very close with closely associated technically with some of the planet scale internet properties. Founded by Monty, it's a very old team, like started in 1982. The history is like Sunbot, and and the core MySQL engineers left Sun for good. Um, Oracle bought Sun and MariaDB Foundation. So this is something very interesting, right? MariaDB, uh, we strongly recommend our customers MariaDB for one big reason. MariaDB server project is supported by MariaDB Foundation, not for profit. And MariaDB Foundation is never ever going to be owned by a single entity or business or corporation, whatever is that, or a single individual. So it's completely a social innovation powered by a community, um, and all the the repositories are on GitHub. All of the source repositories of MariaDB server are on GitHub, managed by MariaDB Foundation. So when we reached a very senior, serious level of discussions, like we made one single page for our MinervaDB internal engineering team to uh, nail it on our walls, or like we have virtual corporation like MariaDB. So all of us work from home. So all of our offices have this checklist. What we should think about when, or what we should advocate on when we are recommending a production-ready database systems for an enterprise. A strong community committer, because support is the lifeline of the database systems. Um, Bug database transparency, which is human managed, approved, managed, approved, and the visibility to general public. And how do we troubleshoot for performance, um, uh, for uh, for tuning the database systems, and the tools for reliability and archiving, security. So we started writing out like, hey, we need definitely a point-in-time recovery database recovery tool. That's very important. Should power replication. We should have load balancer, native load balancers. That means they should be aware of how MariaDB systems work, and what are the future commitments or complexities with open source licensing. Uh, So who owns the database? There were several people who were the owners of database. Initially, we thought like our meetings are going to be only with the DBA, so database architect, or some data SRE or production engineering team. Uh, but then it started growing. We started even talking to the CEO. We started even talking to the board. Board was curious about how severe can be impact if there was something goes wrong during the migration, post migration, data theft. Some of the government bodies, they were like, hey, we will have the statutory audit on the transactions, especially on the payment cards, um, card payment industry, right? Like, we have every quarter we look at all the transactions on the categories what we qualify. That means we need the entire transaction history, the origination, the workflow, and the destination. We need the audit of every of things. So we spoke to them. We worked on the audit matrices, how it looked like. Um, so interestingly, we started realizing that in a data-powered economy, right? What do you call data nomi today? It is not that the ownership of data is just with the DBA. Technically, it is always DBA the owner of the database system. But then there are different stakeholders, and all these stakeholders look for how data infrastructure can benefit their business. And this included both technical and functional interface and operations, which include like who approves a change in database systems parameters, who decides which matrices are going to be monitored, who approves high availability architecture for database infrastructure. But technically, right? We every of our meetings on uh, on the data ops responsibility for MariaDB infrastructure. It's like Um, Technically, the database infrastructure, MariaDB database infrastructure is going to be DBA. And please do not get into the pockets of a compulsive automation disorder. Like automation is great, automate all the repetitive tasks, but then don't get into the phase of automate the task which handles very sensitive information. Um, so don't do that. For example, the alert validation. Please do not automate it. Alerting is great. That's an automatic one. But then who is going to validate or who is going to approve um, any workflow from there? Is it going to be a false alarm or if it's going to be something which needs immediate attention? Please do not automate it. So at some point of time, it has been very clear, evident for us and the customer. So we started feeling like, hey, good, our whatever time we are spending in this our conversation is going to go good because the customer functionally agreed to come out of Oracle to MariaDB. That was a big day. So we wanted to make sure that we'll never make things complex. It's like 90% of your data types in Oracle are what we have shared now, and these are the alternative for them. And when you do the sizing, we personally sit with you because we neither we want you to oversize it, causing a very fragmented, underperforming SQL intensive database application, or even undersize it that you have future data um, operations issues like the data is too big to get accommodated there. And we found that it really fixes, like because we work continuously with some of the largest internet properties which are generously sized, and over a period of time we say like this generously sized always big is good is definitely not good every time. Our learnings we are playing here, right? We'll be very conservative. We'll not oversize it. We want to approve column by column. We approve it because we want this migration to be successful, and that really helped on our second, third phase where we are going to get data into the MariaDB. It's quite straightforward. SQL mode Oracle. That is from MariaDB 10.3, which is PL/SQL compatible database system. Sequences, introduction of sequences in MariaDB 10.3 was much weighted, or sequences were like really because most of the Oracle guys are very very comfortable using sequences for their database architecture. And so like we have a sequence engine, and it's a distributed as a plugin, and that takes care of your sequence generation, auto generation of unique numbers. Okay, this wasn't to offend anyone, right? I was scared when I made this presentation. I was very scared because I was going and talking about this to people who have been working on Oracle for 15 years or 20 years. But then after making this slide, and when I was in the office for presentation, in my customer's office in presentation, right, I was really scared. Like, hey, bye bye Oracle. But then it was good. People are actually happy. They're like, hey, something, we are making things for a bigger internet scale presence of our bank or hospital, and it's going to be an open source database system, which means more security, right? So open source is definitely more secure, and the cost was really a driving factor, right? We are not going to spend any more for complicated licensing terms. We had a party for this, I remember, yeah. The data semantics or the transaction semantics, what I mean by that is the structure of transaction handling in Oracle and MariaDB were very close to each other, right? On InnoDB, right? We declare a transaction and we'll have a SQL and we commit. And Oracle default isolation level is read committed, and there was always a conversation about how repeatable read is different from read committed. So, but there is a differentiation factor we built during our entire conversation of this upgrade. Look, we should be aware about how Oracle's internals work like, where you have multiple memory structures and background processes which talks to your data files. Whereas in MariaDB, it's like you have uh, schema objects are owned by several databases. The schema objects are nothing but the tables, indexes, views, and the physical structure of these logical schema entities are your database files, InnoDB database files. We were using InnoDB in most of the conversation because Oracle to InnoDB closely related. Both are transaction-oriented systems, right? Engine is InnoDB, Oracle is a transaction processing system. Yeah. So this is like quite clear, right? We wanted a system which is ACID compliant, built for sort search, efficient, query performance, full text search support, archiving, data archiving, store complex graph, and cloud ready or cloud efficient. This is like, hey, this one slide would have saved several hours of mine during my meetings. Trust me. When I have won this slide, it's solved, right? Hey, in MariaDB, you have storage engines. If you are talking about ACID compliant, strictly ACID compliant transaction processing row-based system, you have InnoDB and ExtraDB. When you're talking about a columnar data store for big database analytics, big data analytics, right? There is MariaDB columns too. So please do not move the data across storage engine unless you are really confident about it. So this was one, most of our meetings on storage engine choice. I used to tell this. Choose the storage engine best fitted for you. So if you're looking at something, a log structured merge tree storage engine for storage efficiency and write performance, definitely MyRox. But then MyRox, which is RoxDB as a storage engine, is not to supplement InnoDB. Or none of the storage engines are there to supplement each other. They are all going to complement each other. When used appropriately, they all form a very robust ecosystem for data ops, data handling. Archiving to cloud, S3 storage engine. It was very new. By the way, S3 we never got a chance to talk till recently. So when we're talking about observability and visibility to the database infrastructure, we're going to be very clear. Like one, we want to have SQLs monitored by response time. SQLs purely monitored by latency response time, not on throughput, not on the resource usage consumption, and the efficiency of database objects, like which means more focus to index performance, the indexes which are used, redundant, and missing. Can we troubleshoot the query performance by looking at these matrices? This is like, because in Oracle they have always like, so every of a meeting like, hey Shiv, you know something? In Oracle this works like that. How does it work in MariaDB? So I was like, okay, I was making a feature list of Oracle, what they use, a detailed feature list of MariaDB, what we continuously do research in MinervaDB. So the effort was be a proactive sizing and build a proactive team engaged in infrastructure sizing and capacity planning. And how do we validate the availability, or how do we validate the database performance and reliability? So how we can have custom alerting and notification system with integrated workflow to make sure that database infrastructure on MariaDB is going to be reliable. So in Oracle, they talk about, hey, you know something? We have a lot of trace files. We have a lot of statistics packs generated files, a lot of files to troubleshoot. So it's like, okay, what we used to tell to them was like, there is nothing short in MariaDB ecosystem. If you want to troubleshoot MariaDB using logs, you get a lot. use them very carefully. Only use them carefully. You get a lot of information. Slow query log, good if you like. The most recommended one if you want to troubleshoot the query performance um, faster. If you want to find out like the queries by latency and top 3 queries, so top 5 queries by latency, which is impacting database performance by 70% or 80%. If you want to make a list of it, retain it, spend time on it, it's worth because you improve performance by that X percent, like 70%, 80% by tuning 6-7 queries. It's a good exercise. Sorry. Error log, it's good, really good if you want to report MariaDB bugs or any critical errors. General log, you get everything, but you want to be very transparent. There is always, not just in this log, most of our conversation we want to be transparent with this customer, like any customer. There are always some good and bad of everything. General log is going to be resource intensive. You want it, you're going to spend a lot for the storage. And for the compliance and regulatory audits, we strongly recommend audit log, and that really worked. That is quite exciting for them. Like something we have on an open source database system built for the data privacy and security concerns. Or if so, let me tell you an interesting quick story there. When I used to talk to them when I used to talk to my customers on sorry, on troubleshooting performance on MariaDB, on more and more on logs, suddenly one of the DBs, like in Oracle it was more easy. We used to have a lot of tables, data dictionary tables that you get information about. Does that mean that in MariaDB you don't have much data dictionary tables for this? I was like, of course it's there. Of course it's there. It's like fine-tune performance schema, enable performance schema, fine-tune the the variables, and you have access to several data dictionary tables, MariaDB specific data dictionary tables, which you can query and find whatever we're talking about there in the slow query log. You get the same of them or more from the performance schema. So the number of parameters each database systems provide is insane. Like, I'm sorry, I'm just putting this like insane. Like, there's several parameters, very difficult to even remember. Like, it runs in thousands in Oracle. MariaDB is no less too. But then, always what I understood from a customer interest was like more parameters was more problem, right? How we can have very minimalistic performance tuning parameters for an optimal performance. And definitely, MariaDB is highly tolerant unlike many of our proprietary database systems. MariaDB is highly tolerant when it comes to tuning the system parameters or system variables. Right? I use the word parameters after talking a lot with Oracle DBs. Yeah, but that's good. Learning is good. So I was like, hey, you don't need to really work on several parameters for a really optimal performance. Less is more most often. Like InnoDB buffer pool size, which is about how much memory you have for InnoDB. Log file size, it's good, but then it's not too big. It's not too good there. It's good to size it optimally. Handling threads, tuning MariaDB thread handling mechanism. The pool of threads on a web scale works optimal, and most of our benchmarks even it work for customer too. Connection handling, and the InnoDB flush log on each and every individual transaction count. So so this is something like, hey, you're looking at a good performance, you can keep it 0 2, but definitely not for a bank or for any business where every transaction means there's a lot of reputation and a lot of money in that. So we are like, hey, we strongly recommend one. It's okay. Sometimes reliability stands more than the performance, and that was good. Like um, the conversation was always on the best interest of both, right? And both for us and for MariaDB and definitely for the end customer. So these are the compliance like PCI, GDPR, HIPAA, and medical data access um, control, data access, privacy, and protection laws, uh, and how we arrest the rogue sequels. So, like I said, right, the compliance was always a big topic of interest, or the very serious topic, like how we make sure that our card processing systems are safe, and how the transactions are audited. Like I said, it's an ISV with a lot of customers across Europe. So how we make sure that GDPR compliance is validated, um, how the health care data is protected, um, how we can build an end-to-end encryption on MariaDB. So MariaDB provide data protection for both in, uh, in transport as well as at rest was really interesting for them. So as the advanced encryption standard for the data at rest and transport layer security algorithms on data in motion um, gives a clear indication of how we are um, building or proposing a MariaDB infrastructure which uh, protects the data, right? Which makes sure that data is safe in rest as well as in transport. Data masking and SQL injection blocking SQL injection attempts with MariaDB firewall configured in max scale. Make sure that like your database infrastructure is protected against the face attacks like DOS and DDoS, denial of service and distributed denial of service. This is like very important, right? There should not be like any data reliability issues when you are building a financial system or a healthcare system. So we found this quite serious focus. This section is completely was talking about it, like how we can use MariaDB Proxy to build a very robust transaction, the safe and secure transaction processing system with very robust firewall rules. Also, like how we can build the database infrastructure operations on the results set size. Even if someone get in, they can't pull down so much of queries. Like how we can restrict on the result set. So the firewall was purely built. The rule of the firewall was purely built on on the areas like the queries from each user is strictly controlled by the duration, the time of the day, the type of the query. Even look, these are all even from the legitimate bank employees or the bank partners. But then not all the queries at all the time of the business is not acceptable. Not all the query type is acceptable. Also, the syntax like there is a common syntax which application the ISV is rolled out as an API to access the data. But then we maintained a strict syntax rule that is approved by the business, and integrated at the load balancers like MariaDB Max scale to make sure that queries are strictly controlled, orchestrated at a database firewall. So data obfuscation was about, data is always encrypted, safe. So when you're using InnoDB or ExtraDB, it's like you can encrypt all the tables or even the selected ones. Aria works good for all the tables, but then you have a prerequisite of page. So when our conversation started close to getting MariaDB in production, 99% of the time the conversation is like InnoDB compatible, because something as I told before, right? Very close to Oracle, right? So it's just like InnoDB. And we've been upfront, right? All these the data encryption, data security, uh, there are there are exceptions actually, right? The log files are exempted, which include audit logs, locality log, error log, general log. So that means that you need to work hard. There are definitely threat areas, but then it's been notified in advance. MariaDB audit plugin records everything, which includes the host username, the queries accessed, queries executed, and the tables accessed. That is very important. This slide was very important for us because we need to make sure that 7 out of 10 times banks engaged in the payment system, in the payment functions of the bank, and the payment card industry is highly governed by respective statutory law of the land. So the audit reports, like they're very expensive. Like when I say expensive, they're like they're highly respected reports. Than respect, I would say, like they're very key reports for the surveillance auditing of the banks. So reliability. So we want to put it very clearly. Like we can't say that there is a solution for all the problems. There are some problems are solved. Some problems there are dependencies. Like for example, power outages. When you're talking about data reliability, if you have a power outage issues, like then you cannot blame database system. So what you can blame database system, what you can't blame database system for. You can blame database system for power outages. You can blame for a hardware software. You cannot blame database system for a power outage. You can't blame a database system for a hardware failure. Software failure, yes, like database system itself is failing maybe due to a bug or configured wrongly. The human error, yes, like you can blame the application engineers. DBA is definitely allowing everybody to have the equal access. Like somebody went ahead other than DBA or table or dropped a table. Definitely DBA is responsible for that. Not everybody should be responsible for that. Data theft, to an extent, database team, database infrastructure operations team. Natural disaster, not completely responsible. And then how we can make systems which are definitely not going to be a single point of failure. So include, so these are like directly accounted to database infrastructure operations team, or DBAs, or data SRAs, we will call them. Standby server investment, hard backups, testing and validation of the backups, archiving, delayed slaves. The backup tools, the backup options, like what are the backup in MariaDB? Like it's been like there have been several backup strategies. Each one of them carry their own importance. Like logical backup definitely is not recommended in a production online. It's not definitely an online backup. But then the logical backup is also important one, which happens in every bank every 15 days. That's a news for me. This is we do have customers in internet space also. They use logical backup because one, you can it's a highly reliable backup. You can edit the backup. Hard backup, which is an online backup. Incremental full backup. So these are like it's a direct go for us. Like here, does MariaDB support all this? Of course, right? You can use MariaDB Backup. So MariaDB Backup is in the Maria Backup, which can do a full backup, restore, which can do an incremental backup and restore, can do a partial backup and restore. Like, in fact, backup and restoration, our conversation used to go very fast because Maria Backup provides everything, and the logical backup is supported. So, like I said, our most of the meetings are like we need to make sure that there's zero downtime. Technically, it was like debatable, right? And it is not possible. But then, functionally, from a database infrastructure operations, because it's going to be a database migration, database vendor migration from Oracle to MariaDB, right? So, how do you make a system which is going to be and this diagram was like was strong enough to convince the entire business functionally. The synchronous replication makes sure that there is going to be no transaction latency between the master and slaves. All the nodes in a replication infrastructure are going to be synchronous on a transaction level. The load balancer takes care of, which is MariaDB max scale, takes care of failover and archiving to build a very lean database infrastructure operations. That is, like, primary database is always retained lean. Max scale with MQ and T filters was taking care of archiving from the primary database cluster infrastructure to an archive database systems too. Thank you. Thank you for giving me an opportunity to share the story, like how we spent our time to upgrade, migrate um, um, three of largest ISVs with a great footprint in Americas and Asia Pacific to migrate from Oracle to MariaDB. Was interesting, a lot of learning, a lot of good, was worth effort, but though we spent a lot of time, which is good. It was a lot of learning, a lot of experience, and it was a good effort because we could migrate more than 8 banks in last 23 months to MariaDB. Some of the largest hospitals in Middle East, in Americas, and in Asia. You can write to me at shiv@minervadb.com. I accept almost all of my LinkedIn invites. Follow me on Twitter, our Facebook page too. So we are hiring. MinervaDB is hiring. Contact me if you're a DevOps guy, if you're a DevOps guy, if you're a database engineer. Happy to talk to you. Thank you.